50 Ks, how far is it from his place to the edge of space?
Well, that is the question, right?
Oh, well, yeah, roughly 1,200 kilometers, right? You're looking through much more atmosphere, so you get a bigger angle change.
And you were granted the most amount of refraction in terms of leniency of how much refraction you could
Yeah,
apply.
I'm
Hence the
happy with standard
atmospheric.
refraction here.
Okay, standard refraction doesn't lift the mountain high enough to match the globe prediction.
What? The globe prediction is with standard refraction. I don't even know what you mean by that.
Okay, so you're saying that it should be two
219.
degrees and 22 arc minutes, right?
That's the star with refraction, and the mountain
Right.
should be 219 with refraction. So they're
Okay,
still 3 arc minutes apart.
so you're saying that when you hire your surveyors to come in at night, because you're going to do it at the same time, right?
Why?
To get the same type of effects at night, because that's when you took the
Yeah.
observation, bro.
Right,
Tune
but the
into
question
the
is
PZO
the
stream real
angle
quick,
going to
Roohif.
change? Is the angle going to
Roohif
change
here.
between day and night? You guys got to get your story straight. Either there is refraction or there isn't. And if there's no refraction, then it doesn't
Dude,
matter between
1
day
second,
and night.
dog. Mike's position isn't that refraction doesn't exist. It's that the coefficients that are used to make observations,
Match the globe.
match the globe.
Okay.
So
what is
so
the predicted
hold
angle
on.
for the star?
At 2:31 at 6 a.m. in the morning or whatever time it was that you read out, that angle would be 2 degrees 31 arc minutes, and that's the angle that it was
that's
when
not
the
the
star
prediction.
was blocked.
That's not the prediction, though. The prediction is 222 for the star with refraction.
From his position on the globe ground, not
Right.
from the mountain.
Where do you think you should make the prediction from?
But bro, he measured
What?
it.
No. How about we make the prediction from the
Prediction is
moon?
wrong.
Let's make the prediction from the moon.
But bro, Stellarium's prediction was wrong. That's our whole point.
Okay.
That's the entire point of the
So,
presentation.
right.
The
Okay,
entire point of
so
the
you
presentation is
can't
Stellarium's
use it.
prediction was wrong.
Right, so you can't use it to confirm your angle,
But the Stellarium is the glob.
right? Is it
Okay,
accurate?
so-
Yes or no?
Right.
It's accurate to the glob.
No. Stellarium gives you an angle
glob.
to the star. Does that angle match reality, yes or no?
It's not what he measured.
Oh, that's not the question. Stellarium gives you an angle, a predicted angle. If you point your telescope or whatever at that angle, will you see the star?
He didn't, so no. Not in this case.
Okay, so Stellarium, throw out Stellarium. You cannot use Stellarium to confirm the angle to the mountain.
Dude,
so
it's
now we
crazy
can't
how you're
use
spinning this.
Stellarium?
Yeah,
What?
it's crazy how you're spinning this.
No,
So
you
now-
guys just said that Stellarium doesn't work.
Whoa,
No,
whoa,
we
whoa,
just
whoa,
said
whoa.
it didn't match what he measured.
So
right?
I
are
agree.
you throwing out
I agree it
Stellarium
didn't.
totally? It's not a useful
I'm
tool
not.
anymore?
No, I'm not. I think Stellarium
So
is
you
super accurate.
Okay, so you're sticking by what Stellarium said.
Yes.
Okay.
2 degrees, 22 minutes at the time of his sea star time lapse. Not
Okay, do you see
2:31.
this? Let me ask you something. You see this lower star? Are you looking at my stream?
I can't actually. No, I can't get onto
Yeah,
your
you can.
stream. Hold on.
Just click it.
No, I literally can't. Like I'll
Control-
if I'll. Eh?
Control
Oh,
R.
hang on. There, now I can. Hold on. Boom.
Okay, you see
Give me a
this
sec.
lower star?
Hang on. Still loading. There you go. Yep.
Okay. In order for this star to be occulted by the mountain at the time stamp that he has, regardless of what point he is at, right? Like, it doesn't matter what he's pointing at. If he's where he says he was at his house, and the mountain's where it is, and the star's where it's said to be on Stellarium, it could not be occulted by that mountain at that time. Because whether he's pointing at 231 or whatever, the light from the star would have to be going upwards towards the mountain and then back down the other side towards him.
It's curving, yes. But why can't a mountain block a curved path? What's the problem with that?
So you think the light's bending up and then back down?
It's probably
Why
not
not?
going up. No, probably not going up.
It'd have to go up.
No, it's fucking.
Because it's
still
actually
2 degrees
it's actually
up, right?
lower than it's actually lower than the mountain, right? The actual physical measurement of the star is 205, And
Yeah,
the
which
mountain
is still 2
physical is
degrees up.
217.
Yeah, still 2 degrees up, right?
So the mountain's actually higher than the star, though, right?
In terms of from his position, the apparent
I'm talking about uncorrected
angle.
angle.
Uncorrected, yeah, then the star would be below that line of sight between him and the top of the mountain. Yeah, of course, by like
Right.
14 arc minutes.
Right. And so a star can't be blocked by a refracted image, right? It has to be blocked by a physical thing, right?
Yes, but it's a curved path. What is the issue
But it would be
with the
curving up
mountain?
to get over the mountain, right?
No, not up. It's still 2 degrees above horizontal.
No,
right?
no, 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 no. You just admitted that the star is below the mountain. You
I
said it's
said below
short.
that line of sight. That's not what I said. I said below the line of sight.
Okay, relative to the
Right.
observer on the ground and the angle he
Yes.
takes to look at these two objects,
Yep.
physically, unrefracted, physically, a true, like, dead reckoning line, the
Yep.
star is below the mountain peak.
Below that line of sight, yes, by 14 arc minutes.
Oh, okay.
Yes, doesn't have to be going up, all right? Doesn't have to be going up. It's just below that line of sight.
Well, it would be going up.
No.
We could extend these lines
He's
into
still looking. He's still looking at a 2-degree angle, right? It's up.
Okay, bro.
Yes, 2 degrees is positive angle, right? He's looking up.
Uh-huh.
Correct? Right. So the light's not going up.
And this star is lower than the mountain, right?
Lower than that line of sight for the third time.
All right.
Do you want me to draw it properly?
Relative to the observer on the ground,
Mhm.
because the baseline's curved, right?
Yep.
Relative to the observer on the ground, the angle to the star is lower than that of the mountain, physically speaking, right?
It's lower than that line of sight.
Oh,
Right. So the line of sight is going up. Right. Line of sight is going up.
So does the star get blocked by the physical mountain or the refracted image of the mountain?
The starlight gets blocked by the physical mountain. Again, what is the
Okay.
issue with
So
a
shouldn't
curved path? What is the issue with a curved path being blocked by a physical object?
Roohif, he's able to literally see the star and see the exact moment it becomes occulted.
Yes, I'm aware.
Okay, so shouldn't the moment it becomes occulted be the moment that the star crosses the physical line of the mountain, not the refracted line?
Not the straight line, no, because the light takes a curved path. This is not. I need to draw this. Like, you guys are struggling. Let me draw it.
I don't think we're the ones struggling here.
Yeah, we're
Rufus.
not struggling, dude. You're cognizing
I'm
yourself
sure.
into oblivion right now.
All right.
Yeah, Roohif, we all know what you
Yeah,
need. You
go ahead and
need
draw it,
a
Roohif.
I love
dedicated
that.
atmosphere
I
in the
love that
light.
we have a glober claiming curved light path here. I just find that hilarious.
Refraction.
Bendy light is
Right, let me
is his
draw it.
solution. Bendy light.
Yeah, light bends in the atmosphere. I mean, you can deny it, I guess, but whatever.
Well, I would like to see Rubik's drawing.
I heard you were an art major, Ruhif.
I'm really
Just
not.
word
This is going
around
to be
the
fucking
street.
atrocious. This is going to be atrocious. What else we got? Make the mountain up here.
Yeah, Roohif.
All right, this is
sooner or
going to be
later,
a
you're gonna have to
curve.
just acknowledge that the atmosphere and the light is not
Gregory,
dedicated to hide
your voice is already
Oh,
grating on me,
Hold on
Jeff.
one second. Just
Hold
let
on,
him
Greg.
let him draw out the exact same thing PZO just drew.
Shit, hold on. Can I
Go ahead.
move the dot
Yeah,
now?
I was just saying that the atmosphere and the light, they're gonna have to acknowledge sooner or later, is not dedicated to hide your sphere, to protect you from reputations. It's not.
Is that curved enough?
Nope.
No, all right.
Because you gotta remember that whole entire angle to the mountain is like
Oh, I can't believe it.
2.5 degrees, and the angle to the star is supposed to be physically like just over 2 degrees,
Yep.
so it's gonna be a large percentage.
Is that better?
Yeah.
All right, star's over here. Cool.
You need orange because I can't see good because I got my blue light filter.
Oh, fuck.
Just click the
Too
orange button at
orange.
the top right. The star. Just click that.
Yep.
Yep. Click Control Z. Control. Yeah, there you go.
Yeah.
Jesus said he's got nightlight mode on.
There you go.
Hilarious.
All right, so the path that the light takes is curved, blocked by a physical mountain. I don't see what the big issue with that is.
Wouldn't it predict a different elevation angle for an obstruction on the mountain?
The obstruction, the elevation angle for the mountain
For
should
the
be
observation on the
219.
mountain, the observer. Like if you go to the mountaintop, right? If you go to the mountaintop and it's curving like that, it would be curving to the mountaintop as well. So shouldn't you have
Yeah.
a different angle from the mountaintop?
But we're not on the mountaintop.
What would be the prediction for the mountaintop?
233, maybe. I don't know. I have to look it up.
But would it follow that curved line or a straight line if you're up on top of the mountain?
Yeah, follow the curve line.
Okay. So we can draw a straight line to the mountain
No,
and a curved line to the star.
no. We draw a curved line to the mountain.
Uh-huh.
It's
And so-
always refraction. Always.
Uh-huh. And the fact that the star is up in the sky, coming down, 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 right?
Yep.
At the moment that the star is occulted by the mountain.
Yep.
Physically, I'm not talking about refraction, right?
No, we're just talking about
Yeah.
the path of the light, right? The
Yeah, but
light.
it's
Hold on.
physically obstructed, though. Yeah, go ahead.
Yeah, the
When
light
it-
hits the mountain. Yes, it doesn't reach your
yeah.
eye.
So it's physically obstructed at a point when the angles are vastly different, is what you're saying?
Geometrically, yeah, they're 14 minutes different. Yeah.
Uh-huh. So you have in your model physical objects being blocked by apparent positions.
The apparent position. So all it is green good.
Yeah.
So the apparent position. So the angle at which you see.
You need to lower it a little bit.
It's good enough, isn't it? There you go. That's good enough. So this is the angle. This green line is the angle at which you see the star and the mountain. So there's a little bit of difference. There's a little bit of difference in the mountain and the angle, and a big
Think it should be
difference. This
tangent
is
to the
14.
peak.
No,
Why?
no. This is the angle at which the light's coming into your eyes. This is where you see it. Geometrically, it's here. This here is the 2 arc minutes difference right here, and this here is the 14 arc minutes, or 16.
What?
16, sorry.
Two different types of refraction you're
No.
invoking.
No.
Well, he
This
is. He's saying
one-
the mountain is refracted with one and the star is refracted with the other.
Exactly. That's exactly what he's saying.
This is 50 kilometers between him and the mountain. Right? This is roughly 1,200 kilometers. You're going to get more of an angle change
1,200 kilometers from where to where?
from here to the edge of the atmosphere.
The edge of the atmosphere, 1,200 kilometers.
Yeah. Approximately. It's a long way.
1,200 kilometers. 1.2 million meters. Okay, we're like talking like 700 miles. Anyways, how
Yeah,
can
sorry.
it match a flat baseline prediction in two different points?
Well,
One-
again, you said it matches twice, but then you've thrown
Yes.
out stellarium, right?
Hold on a second. It matches 231, which is the plane trig,
Yes.
to the mountain peak. Okay. It also matches the star from the mountain peak.
We're not on the fucking mountain, Pete Piezo. We're not on
I
the
know
mountain.
we're not.
We're at his house. So what is the
So-
prediction
so hold
from
on.
his house?
Are we throwing out stellarium or did we just turn
Oh,
refraction?
I'm not. I'm not.
No,
Are
no.
you?
I'm saying we. I'm asking about we.
Yeah,
Did we throw out stellarium or did we just turn refraction off? Because
that's the question for you.
well, when we use the quote unquote uncorrected angle to the mountain, and then we apply the formula that you used for the star, which is being
Mhm.
occulted by the mountain, to the mountain, it turns out it matches what we measure
Right.
with a flat
Why?
baseline.
Why are you adding 1,200 kilometers of refraction to a mountain that's 50 k's away?
It matches the physical
Is
occultation.
it correct? Is it correct? Should you
It
apply
matches what
1,200
was
kilometers of
measured.
refraction?
What do you mean? Is it correct? We're not talking about a thought experiment. We're talking about what he went outside and looked through a physical instrument and wrote
Yep.
down.
Yes.
So you're the
And
one
he
doing
got
a thought
231.
experiment right now. Yeah,
Right.
you're the
What
one
is the
doing a thought
correct
experiment.
prediction for the mountain?
The
231
flat
without
baseline.
refraction. Yep. That's the correct prediction, 231. What is
Yeah.
the correct prediction for the star?
So would you agree? What he measured, you already did it earlier. I just want to make sure that you're consistent with yourself. Would you agree that what he measured matches the prediction for plane trig?
Yes.
Yeah.
Yep, with no refraction. Yep.
Okay.
231, and he measured
you.
230, wasn't it? Yeah. Which is
Yeah,
close enough.
so the only thing you have left to escape from this is to say that his measurement was wrong.
Correct. Correct.
Okay. Well,
And
why are
how
we going
much
back and forth and
money?
arguing then? Why didn't we just skip to that instead of arguing like this nonsense right now?
Well, you're trying to use stellarium to confirm the angle to the mountain, but you won't tell me what your, prediction from his house to the star is with stellarium.
I already covered that. It's using the glob baseline, right?
I don't
So
care. Is that angle correct? If I'm at
on
my
the glob,
house, no. Like I said, stellarium gives you an angle. If I point my telescope at that angle, will I see the star?
he saw the star, right?
Right. So is
Okay.
stellarium correct?
So without refraction, he saw the star.
Okay, so without refraction, it should be at 206.
Yeah.
He measured 230.
So once again, the position he's taking, just to be clear, is that refraction for celestial bodies is not what actually happens. The celestial bodies are not being refracted. That's his position.
Okay,
The
so its
position that
prediction
they
is
measure.
206.
The prediction that they measure, right? The prediction that they measure, that he measured was a flat baseline prediction. So he's saying that
That's for the mountain, yes.
He's saying that refraction makes up the difference between a flat and a curved baseline.
Right. He made a prediction for the mountain. What was his star prediction from his house?
231
No, it's not. It was
on a
206.
flat baseline.
No, open stellarium and tell
On
me
a
what the number
That's
is.
not a flat baseline. That's a curved
Oh,
baseline.
Jesus. Okay, so if I open stellarium and I point my telescope at the angle that stellarium says, will I see the star? Yes. Yes, I will. Right, so the angle that he should have
That's
pointed.
not what he did. Bro, you're saying what he should have. We're telling you what he did. That's what I'm telling you.
I understand.
You're doing a thought experiment, and you're saying,
No, do you understand? Right, either stellarium is correct or it's not. Which one is it?
For the star or for the ground, because they're different.
Stellarium, the angle that it gives you, is that angle correct or not?
So that's the point, Roohif, is that the
It's not an answer.
angle. Hold on. The angle that it predicted for the terrestrial measurement was correct if we assume celestial refraction. The angle that it predicted. I'm not finished. Please don't interrupt me after every 3 words.
All right. It's a simple question though.
Please.
The angle that it predicted for the celestial measurement was not correct neither with nor without refraction. However, if we use the object in the middle, which is the physical occultation object, if we use that as the base point to trace the line to the star, we can continue the line to his house, and it measures where it was occulted. It matches where it was occulted.
Okay. Does stellarium predict angles to mountains?
Only if you incorporate.
It's a no,
the
Peter. So it's a
celestial
no.
refraction.
The answer is no. Stellarium does not predict angles to mountains. Does stellarium predict angles
If we
to stars?
turn refraction off, and then we use the celestial refraction formula for his mountain at that distance, then it was
Jesus,
correct.
we're going around in circles. We're going around in circles. Should you apply 1,200 kilometers of refraction to a mountain 50 kilometers away? Yes or no?
Not in your model. That's the whole point. But it works fine for
should
us.
Should you?
No,
Why would you
no,
use 1,200 kilometers of refraction?
Dude, Can you like open your mouth without straw manning someone?
I'm asking you a question. How is a question a straw man?
You're trying to ask me like a loaded question. That's not what we're doing. Okay. We are saying that if you use a flat baseline, you do not have to incorporate refraction in the celestial theodolite measurement.
Yeah, we only have to use plain trig. That's the point.
Right. Okay. And are you using the star or occulting as confirmation of the accuracy of his measurement?
We're using the occultation of the star to treat the position of the star as a true position, and then we're comparing that true position of the star being occulted from where he saw it using plain trig with what
Oh.
the globe predicts at the physical location where it was being occulted.
Okay, so let's go to the moon and predict an angle to a star rather than his house.
No,
Why are
the
you going to the mountain?
the
Why?
mountain is where the mountain is what is occulting the star.
Right, but it's not where he is. It's not where he made his measurement.
Okay, so
This is ridiculous.
did you hear what I said though?
Yes,
Our position is that we can
is
use
retarded.
we
And
can
add
use straight lines, right? Plain trig. We can use straight lines to trace real physical positions and angles. So if we do that, we use plain trig. We trace a straight line on the baseline, a straight line on the hypotenuse to the mountaintop. We get 231.
Yep.
We also wait for the star to be occulted by that straight line at 231. Then at that moment that it's occulted by that straight line, we then change our location to the object that is doing the occulting and check
Why?
what the angle to the star is supposed to be on the globe.
Why not check it from Denver? Like, what's the prediction from Denver for that star at that time?
I don't know. It's irrelevant.
Right. I agree it's irrelevant. So why are you doing it from the mountain? What is the prediction
Because the mountain
for the
is blocking the
star?
star.
Right. What is the prediction for the angle to the star
I
from
do-
his house?
Yo, this is
Oh.
getting hella circular and repetitive.
Yes.
And nah.
What? So well, hang on. Did we
Nah.
did
So
we get
Reuben,
anywhere? Have
So
we
you admit
thrown out
that your
Stellarium?
you admit that your only escape mechanism is that Dr. Mike Heffron's measurements were completely wrong.
Yes, and I will bet
That's it.
money on it. Let's
Okay.
go.
Okay.
How much do you want to bet?
Cool. So you're telling me that if you were to go there at what's this time again?
Time doesn't matter unless you want to incorporate refraction. Which he
No,
doesn't.
we want you to, if you want to repeat the measurement, you need to also get the occultation of the star.
The star's not going to be in the same place at the same time again until next year, right?
Okay, so it's going to be occulted at a different time. We need it to him to
Right.
be there whenever the star gets occulted.
Right. So is
it's
the
gonna be at
height
night.
of the mountain, is the angle to the mountain going to change through the day?
Yes.
Okay, so please get Dr. Heffron to revise his predicted angle to the mountain.
Wait. Predicted angle to the mountain
Yeah.
using what?
It's the angle at night, bro.
Okay, is that going to change
Refraction or
the
not
angle during the day?
refraction? What do you mean?
Well, I would always say refraction is always there. So is he
So-
going to incorporate refraction or no?
The angle he measured at night matched the FE prediction, and it was
Yep.
confirmed by the occultation of the star, which also matched the
going around in
predicted
circles.
angle from that location. Yeah, I'm just you've agreed. You already agreed because I asked you directly. Did his measurement that he claimed to measure match the FE prediction? You said yes, it did.
Yes.
And then you said that your position is that if his measurement's correct, right, that it would support our position, but you think his measurement's wrong.
Yes.
Okay.
See
You
how,
also
see
said
how
the
easy it
occultation-
is. Hang on. See how easy it is to answer a question with a straight yes or no.
You're
Continue.
asking me a question about my prediction but you're asking me in terms of the glob, which is not my prediction. So you're
No.
literally
I'm
asking
not
me a
asking
loaded
about the globe.
question.
No, I'm asking you: does Stellarium give you
His
an accurate angle? Yes or no?
his measurement cannot be wrong because the star was being occulted at the time he predicted without refraction corrections.
Right. So what was that angle? 231, right?
231.
Right. So
Yes.
stellarium without refraction gave 206, and with refraction 222. Is stellarium wrong?
It was wrong for this.
Okay, so you can't use it to confirm his measurement
Oh
to
my
the mountain.
gosh. It's only I can't use it to
Oh
confirm the
man.
glob. You're
All
like
right.
missing
I
out.
think
Like
we're just
I
going around
don't
in circles,
understand.
aren't we?
No,
We're just
bro.
going around in
Like
circles. Yeah.
you're literally at that point, at the point when
I
you
need to
realize
draw.
that what he measured didn't match stellarium, you're saying that it makes us wrong and not you. That's
I
the
need to draw a
logical
flow
disconnect
chart.
here.
Need to draw a flow chart that says, is stellarium wrong? Yes, no, go down this path. Like,
Dude, it's not a binary choice. It's in terms of the glob, right? Yeah, its
no.
predicted star angle was wrong.
Okay, so you can't use it to confirm the measurement to the mountain.
No, we can't use it to confirm the glob. The measurement to the
Red.
mountain was confirmed by the
Regardless,
fact that the star was occulted according to a flat baseline plane trig measurement.
right? Regardless of whether stellarium is a globe thing or not, right? The question is, does it give you an accurate prediction? The answer is yes. With refraction, by the way, yes, it does.
Not according to what he measured. That's what we're
Okay.
discussing right now.
Right. That's why I'm saying his measurement's wrong. Because with refraction, the star would have occulted at
Well, I'm glad that
222.
I'm glad that we've acknowledged the implications of his measurements. That
Yeah.
if